Hello, this is Abigail Lewis, and this is my Chapter 6 assessment. Okay, so for our first problem, it says let a of x equal 3x plus 2 and b of x equal 4x plus 3. Find a times b. So you're going to write it like this, and then you have to FOIL it. So 3x times 4x is 12x squared. 3x times 3 is 9x. 2 times 4x is 8x, and 2 times 3 is 6. And you can add that together. 12x squared plus 9 plus 8 is 17x plus 6, giving you your final answer of 12x squared plus 17x plus 6. Okay, so for our next question from 6.1, it says let c of x equals 6x squared plus 5x plus 3 and d of x equal 2x squared minus x plus 1. Find c plus d. So you write 6x squared plus 5x plus 3 plus 2x squared minus x plus 1. So 6x squared plus 2x squared is 8x squared. 5x plus negative x is 4x, and 3 plus 1 is 4, giving you final answer of 8x squared plus 4x plus 4. Okay, our next question from 6.2 is find the inverse of y equals 5x minus 4. So the steps to finding an inverse is to switch the x and the y and then solve for y. So if you switch this, it would be x equals 5y minus 4, and then you can add 4 to each side. X plus 4 equals 5y, and then divide by 5, giving you y to the negative 1, which is the inverse, equals x plus 4 over 5. Okay, so for our next question from 6.2, it's asking are f of x and g of x inverses? F of x is 2x plus 5, and g of x is x minus 5 over 2. So the way you want to do this is do f of g of x, and then also do g of f of x. And you want it to equal x, because that means it's an inverse. So for f of g of x, it would be 2, and then x minus 5 over 2 plus 5, and these cancel each other out, so then it's x minus 5 plus 5, and then negative 5 plus 5 is 0, so then it's just x. So this one is an inverse, and then this one, you plug in 2x plus 5 for the x right there, and then minus 5 divided by 2, so that gives you, if you add 5 and subtract 5, that's 0, so then that's 2x over 2, and then those cancel out, which gives you x. So yes, inverses, they are inverses. Okay, our question for 6.3 is saying identify the domain and the range. So the domain is the x values and the range is the y values. So to find the domain of an equation like this, you set what's under the radical is greater than or equal to 0. So domain would be x minus 4 is greater than or equal to 0, and then you add 4 to both sides, giving you x is greater than or equal to 4. And then for the range, it's just what's left over here, and that is y is greater than or equal to negative 6, because, yeah. Okay, for our first question of 6.4, it's saying to simplify this expression. So positive negative square root of 64x to the 8th. So you put the positive negative here, and then the square root of 64 equals 8, because 8 times 8 equals 64. So that's 8, and then square root of x to the 8 is x to the 4th, because 4 times 2 equals 8. So your final answer would be positive negative x to the 4th. Okay, so for our next question of 6.4, it's saying to evaluate the expression square root of negative 25 x to the 6th, y to the 10th. So this is the same thing as negative 1 times, this breaks down into 5 and 5, so times 5 times 5, and then x to the 6th, y to the 10th. I'm not going to write all of those out. So 5, you can take 5 out, and then the square root of negative 1 is the same thing as I, so you can also take that out. And then x to the 6th, the square root of those is, because this is a 2 here, so that's basically x to the 3rd, and then 10 over 2 would be y to the 5th, giving you 5i x to the 3rd, y to the 5th. And then you can put this in those little brackets since it's an even number and an odd exponent. Okay, for 6.6, it's saying to evaluate the expression 81 to the 1/4. So this is the same thing as writing this, and then basically you want to break this down to see what number times itself 4 times is equal to 81, and in this case it's 3 times 3 times 3 times 3 equals 81, so the answer would just be 3. Okay, for 6.5, it's saying to multiply the radicals 4 root 5 plus 2 root 6 times 3 root 2 plus 4. So basically all you want to do for this is FOIL, so you do 4 root 5 times 3 root 2, which is, because 4 times 3 is 12, and then 5 times 2 is 10, plus 4 root 5 times 4, and 4 times 4 is 16 root 5, plus 2 root 6 times 3 root 2, which would be 6 root 12, and then add that to 2 root 6 plus 4, which would be 8 root 6, and then basically just put this in order, so 6 root 12 plus 12 root 10 plus 8 root 6 plus 16 root 5 is your final answer. And for our last problem, which is 6.7, it is saying to solve the equation, the cube root of 2x plus 7 minus 5 equals 4. So for the first step in this, since this isn't under the radical, you want to add this to the other side. So it would be the cube root of 2x plus 7 equals 9. And then to get rid of this radical here, you want to multiply each side by 3, giving you, to the 3rd power, 2x plus 7 equals 9 times 9 times 9 is 729. And then you want to subtract 7 from each side, giving you 2x equals 722. And then divide by 2. And 722 divided by 2 is 361, which is your final answer.